Hello everyone, this is Hadi Taghavifar with collaboration of Professor Perera from the UIT University, Arctic University of Norway. The investigation on life cycle assessment of different fuel types, including diesel as baseline and LNG and methanol as potential futuristic fuels with different powertrain configuration in dual fuel engine mode. Is organized and will be discussed in detail in the upcoming slides. The outline of this research is organized in four sections. First, we are going to have introduction of our work and what LCC and LCA representative, and then we come to methodology where we have to define the ship navigation route and specify the fuel pathway and the calculation method, and then there are results regarding emissions, energy resources, and economics, and finally we will have our concluding remarks. LCA considers the processes that lead to the final use of a product, and while we are going from the production to the final use, the amount of emission or costing have to be calculated. In this sense, we have to define the boundary of the system, and the inputs and outputs during the processes have to be calculated, and for a pathway and finally for the project, these have to be added together to have the final results. For our fuel case, we by using GPS, we tracked the ship lane for one vessel that we had. So we decided to use two major routes for our ship operation. One of them is a shorter and the other one is the longer uh, distance for the ship operation. And based on that, we calculated the amount of emission and also the costing that we have to afford during these two missions. The block structure, fuel pathway from extraction to transportation and dispatch phase are displayed in this slide. We have four different types of fuels, namely heavy fuel oil diesel and ultra low sulfur diesel, and in each of these block structures we have amount of emission, and the product in each process is shown here in the circles. During each of these processes, an amount of emission is going to be released and they are added until we get to the final stage, which is bulk terminal, that the fuel will be dispatched to different destinations. As can be seen, methanol and LNG require more processing time and more processing structures, and the main engine specification of the ship engine here can be seen. These are very critical in our computational analysis, since the efficiency of the engine determines how much fuel and energy are going to be consumed. And in the lower table we have the specification of different types of diesel, LNG, and methanol. For example, heating value of methanol is lower than diesel, but LNG has higher heating value compared to diesel. So in order to have a fixed amount of energy, we are going to use more methanol and lower LNG, and these characteristics and factors have been taken into account in our final consideration. Life cycle costing has three main components: initial cost that has to be scaled to the time of operation and distance that the vessel is traveling. Then we have life cycle fuel cost, and another one is life cycle maintenance cost, that all of them are linked to the time of operation and the distance that the vessel is operating. This study is featured with the scaled initial costing that it relates the initial cost to the time of operation, because the initial cost is an amount of money that is expended in the first beginning of the project. So in the continue of the project, there is no trace of that. So we have to link this to the time of operation. We use this equation to make this happen, to make initial cost related to the time of operation. The initial cost, for example, for the LNG infrastructure installment is listed here. That for based on our direct link to the engine operation, it comes to something about 2.4 million euro. That has to be scaled later on by the above equation. The LCA results in the production phase in terms of energy and resources used, and the emissions that are classified into minor and major emissions are displayed in this slide. To put it in a nutshell, we can say that LNG has very low water resources and natural gas demand, while methanol requires a very large resources in terms of both renewable energy and resources per kilojoule. The emissions for minor emissions also NOx and carbon monoxide are two major constituents of our minor emissions. We have to pay attention that ultra-low sulfur diesel during the production phase has a considerable amount of SOx released into the atmosphere, and on the other hand, for the major emission for the LNG production, there is a 3% methane that compared to other fuels is a considerable and significant amount that is due to methane slip during the liquefaction of the natural gas. The emission results during transportation and combustion of fuel is displayed in this slide, where fuel type, powertrain mode in single and dual fuel mode, and transportation length are considered as the variables. The combustion of fuel and powertrain constitute different scenarios from S1 to S7 as represented in the table, where the well to tank during fuel production and tank to propeller during the powertrain or transportation are combined and formed S1 to S7. S6, which is LNG powered vessel, shows significant CO2 and SOx reduction, while this case also suffers from high methane slip. This issue can be resolved in dual fuel diesel LNG operated engine in S4. And another point is that between route number 1 and route number 2, there isn't any significant change in emissions, as the bar charts demonstrate a slight emission increase for longer R2 route. About life cycle costing analysis, or LCCA, in the results we see that there is a correlation between the route number 1 and route number 2. If we travel more in a route number 2, there is a more costing requirement for route number 2, and unlike LCA and emission analysis, that there was no correlation here, we can see that there is a correlation between the distance that we travel with the costing that we have to spend. On the other hand, methanol here has the lowest cost, but it requires a very large resources demand. On the other hand, we can see that LNG and diesel are comparable together, and if we apply different SCR or LNG tank or installation and infrastructure, then we have to make compromise in that order. The dual fuel engines make compromise between methanol and diesel, that we have to consider them. The main component of the costing goes to life cycle fuel costing. Under the same engine operational condition and for a given fixed energy output, we can summarize the findings such as number one, methanol is economic but requires huge energy demand and resources. Number two, low sulfur diesel during production gives out more SOx than conventional diesel, while in the combustion phase, there is lower SOx emission for low sulfur diesel. Methane or number three, methane or CH4 for LNG is considerable both during production and combustion. LCC results depend on voyage distance, while uh, LCA or emission content shows insignificant dependence to the distance that the vessel travels. And number five, dual fuel application is an economically feasible plan while to reduce the emissions.